last video, I ran another motor mount using the belt drive and compared that with this motor mount that was made with the gearbox. I went back and looked at the video. It really didn't appear to sound like it was more quieter with the belt drive, but believe me, it was definitely quieter. So the belt drive, you can see I can talk while this is running and you can still hear me. And the camera is actually inside the enclosure. So you can see it's not really that loud. There are, however, a few things that I have come to find out with the current form of this belt drive that I'm not real crazy about. And some of those things are the step pulley design. It just doesn't work with this particular motor. This motor is a 3425 RPM motor. Originally, I had wanted to replace the tapered roller bearings with AC bearings. However, if you're not going to pair them, then you really can't use the AC bearings and get good results. So I decided to stick with the Nachi tapered roller bearings. And they're only really good for up to around 5,400 RPMs. So I don't really need a 2-to-1 pulley ratio to get to 5,400 RPMs. I can just overdrive the motor a little to achieve that. So the pulley is set up the way it is all wrong. It really needs to be more of a 1-to-1 and a single pulley setup. Another problem with this particular design is, if you remember, the pulleys have these 3 pins that slide over the spindle, and I found that depending on where you slide the pulley, it goes on easy, and in some places, if you just turn it one tooth, it's very difficult to get it on, like right there. So I would think, and I may be wrong, I would think that if there's something off in my pins, it would be hard to get on every spot, or easy to get on every spot. So I have to think that there's something wrong with these grooves. Now, I don't know exactly how these are made. I don't know if this is rotated and milled, or if this is drawn through a broach, a spline broach. I don't really know. I do know that the center bore is not concentric, and it's just a rough bore. So you can't really check for concentricity in the bore, at least internally. Now you can check it on the bottom, and I have checked it, and both of these spindles that I have here are actually really good. There's very little run out. Also, the pulleys are a little bit more difficult to make because there's a lot more machining. I had to do all this machining to relieve the bottom of the pulley because their top of the gearbox has this little lip that sticks up, and this has to slide down over that. So that was a little bit more difficult to machine. The top of the spindle had to be threaded for this top hat, which I couldn't do in-house because it would be a interrupted cut because of the way this is, the splines are. Every time it turned, it would cut, stop, and it just, this interrupted cut is really hard to get threads on. You really have to have a good sized machine and one that's got enough power and torque to overcome that. And with Mach 3 having only 1 pulse per revolution, it's not a good way to thread something with an interrupted cut. So I had to send that off and have that threaded at a machine shop, which, believe me, costs an arm and a leg. So I decided to go a different route. Now it cuts fine, it runs fine the way it is, but I couldn't really use the full horsepower of the motor, because if I run this motor at 3,425 RPMs with the 2-to-1, it puts my spindle at around 7,200 RPMs, which is way more than the bearings can handle or should handle. And so you don't want to overheat the bearings. So I've been running it at probably around 1,500 RPMs. So I haven't really been getting the full benefit of the horsepower of the motor and torque. So I want to get back to a 1-to-1 pulley ratio. Another thing that I have found with this particular setup is, because the spindle of the Precision Matthews is like 14¼ inches, I mean, this is a long spindle compared to a 704. And as you tighten up and squeeze the drawbar, I think there's getting some flex in the spindle, because once I tighten up the tool, I can feel that this gets a little tension on it. And I know that that's because this is all tied together, and for some reason just a little bit of flex is getting a little tension on the bearings. I don't really like that. It seems to run fine if you run it around 4,000 RPMs. The bearings don't get overheated or anything, but I think that that might be a problem in the future. Because this is threaded, I had to put 3 set screws on here to keep this concentric. Otherwise it had run out in it. Even nice tight threads would still have a little bit of run out without these set screws, so I had to lock that in there. Another thing is, you can't have this top hat pressing down on this pulley. It just needs to be touching it. If you tighten it up and press down on there, it pulls the drawbar up, or actually it pulls the spindle up, and these bottom bearings here pull up into the cartridge, and it causes it to put tension on the bearings, and they tighten up. I think that's what's causing the problem with the spindle. When you tighten up the drawbar, it's flexing, and it's putting just a little bit of tension on there because it's pulling those bottom bearings up into the race. So even before I installed this, I started thinking about my original plan, which was to invert the quill. However, quill of the machine, the spleen grooves are at the bottom, and that is so that it can be as close to the top bearings as possible. So by inverting it, that would put it way up top, and I think that would just cause more issues. So after talking with some buddies of mine on Skype, we decided to, why not just extend the quill tube. And so that's what we did. I sent Wyatt, I had a couple of these, so I sent them to Wyatt, and he welded on a piece of steel here, as you can see in these photos. Stuck them in the lathe, turned this down, and we threaded the ends here. So this quill tube extension keeps the spleens at the very bottom, but also allows us to slide a pulley on there and connect it with a spanner nut. Now this keeps the spindle independent of the belt drive, and we no longer need to thread the top, and our top hat can just slide down over the top of the spindle. So it's a much better solution, I think, than the current setup. So thanks to Wyatt for putting these Quill tube extensions on here. He did a really nice job. The weld was really nice. You can barely even tell that it was welded, except for just a little spots. And I think it's going to be really nice. So I'm going to get this installed and we're going to try it out and see. And hopefully this will be a better solution than the current setup. So let me get it all installed and we'll see how it does. Okay, so I've got my indicator in here and I want to check the spindle run out. Now this is without the top on at all. This is just with the spindle through the bore. And this is just to check my initial spindle run out so that I can compare that to any changes, whether it gets worse or whatever when I add the quill to it. So let's see if I can zoom in here. A little bit. Looks like about 2/10. Alright, so now that I've got the spindle cartridge in and I've checked that, I'm going to go ahead and assemble and put the top on. Alright, so we have our spindle assembled inside our head. Now in here there are two bearings that ride between this snap ring here and this gear. You can see this edge right here, and that's up against this gear. Now this gear is about a 1/2 inch wide, like so, and then there are two 14mm bearings, 14mm thickness bearings that go in here, and that turns real smooth and real easy. It's a double bearing setup. We know that we introduced some run out into this pulley, but overall I think if you look, you can see that Wyatt did a really nice job on this. You might concede there's just a little bit of deviation there in the concentricity, there you go. And I measured that earlier, it's about 2 thou. I don't think that's going to affect the quill too much. The fact that this is independent of the spindle, I'm hoping it's not going to induce any kind of run out in the spindle. But we won't know until we get this assembled. So let's do that and we'll give it a check. Alright, we've got the lid on. It's just sitting on here. And I want to turn it a little bit. I want to make sure that there's not a whole bunch of wobbling around on my lid here. And it looks pretty good. And I know that since there's not a whole lot of wobbling, everything must be kind of lined up pretty good. So now I just want to put in my alignment pins. Now the head of this mill has these alignment pins, and to remove these you just put a 5mm screw in there and you can take them in and put them out. So just a tip there for you. These pins are tapered slightly, so they go in and out from the top. There's one here and one here. Make sure they're down all the way. And then we'll get these 6mm screws. One here, one here, back two, and then there's these front two that we're using to actually help hold in the riser, so we'll put them in later. Okay, and then now that we've got them kind of snug, make sure everything feels pretty good, I want to just come back and kind of tighten these up a little bit at a time. These don't have to be super tight. At least I don't think so. Alright, Got that tight. Now we can mount our risers. Alright, so I'm going to get these mounted, and I'll get the motor mounted, and then we'll come back and see what we got. Okay, so I've got the new quill in, I've got it all mounted back up. Before I tension the belt, I just want to make sure I can hear. There's a little play between the quill and the spindle, and that's to be expected because they're not tied together any longer, and that's just the way it was with the gearbox. So there might be a little noise with the belt drive from that, but which is fine because I know that now when I tighten up my spindle, it's not going to put any pressure on my tapered roller bearings. So that's what I'm listening for, and that's what I want to have. Alright, so I'm going to put the belt on, get the belt motor tensioned up, and we'll run it and see what we got. Okay, so I've got the belt tensioned and the belt drive in. You can hear we still have the noise. Let's see how loud it is. This is just 500 RPMs. You can kind of hear it clicking and clattering. I'll kind of grab the spindle a little bit and put a load on it, and it quiets down. Let's try 1500 RPM. You can hear it's a lot louder. Let's try 3000 RPM. Quite a bit of racket with, but I expected it to have that clattering in there because, you know, it's not a real tight fit between the spindle, quill, and the spindle, so it's to be expected. So anyhow, I guess now it's just to run some G-code and see how it cuts, and check Spindle Run Out. I checked it without the quill in the gearbox, and I had 2/10 of run out, so I'm going to check it with everything assembled. It should not have affected any of the run out with the quill. If it did, then I know that something's going on, so let me check it. Yeah, not quite 3/10. So that's about what I was getting without the quill. So now I'm trying 20 inches per minute. This puts the chip load around 0.0015. Still 5/1000ths width of cut for a finishing pass. So here we go. tell the chips are smaller. Well, alright, so I've been just running this 3-flute Aluma-Power end mill. I've just been trying to dial it in and see what kind of finishes I can get with the new spindle upgrade. Pretty satisfied overall with the spindle. It does have a little bit of clatter, which is to be expected, because now the spindle and the pulley and the quill, they're all not tied together. So I expect to get that little play and clatter, but that's good. And she's running fine. You can see the finish here. It's really good. And some of the chips that I've been getting, I'm really satisfied overall with these chips. This was about 3/1000ths on the chip load. I was running this at 40 inches per minute, 40/1000ths width of cut, all the way up into some finishing passes I was playing around with. Really nice slivers. So overall, I'm pretty satisfied. I think that this belt drive with this configuration is going to be a whole lot better than the previous version. So that's pretty much it. I'm going to just start running some parts. Next, I'm going to work on the power drawbar. I'm pretty satisfied overall with the belt drive, so now we'll just work on the power drawbar, get this air cylinder mounted up, and start moving forward. I've got to machine the lift plate, so we'll get all that worked out and we'll get all this mounted up, and hopefully we'll have the power drawbar and all done. Alright, so let's we'll turn this on and run through and let you listen to the clatter. There is definitely some clatter here. Can't get any higher here. Tripod. You can hear a little bit of clatter. And let's go up to 1500 RPM. A little bit more on the clatter. It's a little bit louder than it was earlier. 4500. However, as soon as you get some tool engagement, it quiets down somewhat. Overall, I'm really happy. Bearings are not getting hot, so running pretty cool. Overall, pretty satisfied. So thanks for watching the video, guys. If you have any questions or suggestions, please feel free to comment. As always, thanks for watching the video. Thumbs up if you like the video. Please subscribe, and most importantly, be safe.